Hello everyone, today we're going to look at 3.4. 3.4 is probably one of the last review units we're going to see, at least for a while. 3.4 we're looking at factoring. So you should have done factoring last year. Hopefully your teacher showed you diamond and box. If not, that's what I'm going to be working with here today. Diamond and box is one of those tricks in math that works better for students. It's very visually oriented. It takes out a lot of the guess and check work of the way we used to do it a long time ago. And it's honestly just a little bit faster in the long run. So we're going to jump right into that. Before that, though, we need to talk about greatest common factor. So we always want to look for a greatest common factor. We did this in the last video, but just as a quick review, the greatest common factor is what we can take out of all parts. So looking at my first number here, I can take a 3 out of both of these. I can take a 9 out of the first one, but I can't take the 9 out of the second one. I can take 3 out of both. And then my first term here has a y, and my second term has 3 y's. So that means I can only really take one y out. My second term has an x, but my first term does not. So that's all I can take out. So 3y. Now it only asks us to find the greatest common factor. That is, but let's go ahead and actually factor it out. So 9 divided by 3 is 3. Y divided by y is 1. 3 times 1 is just 3. Plus 3 divided by 3 is 1. But I have an x, and then still have 2 y's. We always want to look for a greatest common factor, because if we don't, then what can happen is when we're factoring, we can have these very large numbers that have 20, 30, 40 factors, and no one wants to deal with that. Typically, when you find the GCF and factor that out first, it reduces those numbers down to a manageable level, at most, like 6 or 8. Continuing on, I can take a 2 out of both of these. I can take one R and an S. So 2RS. And whatever we take out, we want to put out front. 3. I had 3 R's. I took 2 out. I took 1 out, so I still have 2. And then 4. Next one. 3X. Take that 3X out. Now, I need to be careful here on this one because, yes, I end up with a 1 and a 1, and typically 1s go away if we're multiplying against them something, but then I don't have anything else that I'm multiplying that against. So I do want to keep a 1 there. I didn't have to keep it here because I had a 3. I didn't have to keep it here because I had an x and a y that was multiplying against. If I don't have anything, if everything goes away, I always want to leave a 1 there. It's probably one of the most common mistakes I see in all of math is when students are dividing stuff, they don't leave a 1 if everything disappears. So again, if everything disappears, leave a 1. For this one, again, I don't need to leave a 1 because I still have something there. Minus Z. Okay, and there we go. I'm going to skip the rest of these. If you have questions on this, please feel free to email me. Okay, how can you factor a polynomial? So there's a bunch of different ways you can factor. There's guess and check, slide and divide, diamond and box, which is what we're going to use today. And there's just lots of ways. Again, it doesn't matter to me what you use. If you're using something other than box, I may ask you to show me what you're doing. I know personally that PhotoMath uses factor by grouping. And honestly, factor by grouping is challenging. But if it works for you, feel free to use that. If you're using a different method, though, I may ask you to show me one more time how you did it. And that's just to check to make sure that you really, truly do understand. Because I want to make sure you understand. Because if you can't factor, the rest of this unit is going to be very challenging for you. So please make sure you're taking the time to actually make sure you're doing this on your own and not having a program do it for you. So again, when we're talking about factoring today, we're going to be talking about the diamond and box method. So that's ax squared plus bx plus c. So when I have a quadratic, and there's a slightly different way to do it if I have a cubic. Right now, let's look at quadratic. So if I have a quadratic, I first want to do a GCF. So step one, GCF, greatest common factor. After I've done that, I'm going to take A times C, and I'm going to put that in the top of my diamond. I'm going to take B and put it in the bottom. After I do that, I need to figure out what two numbers multiply to give me AC and add to give me B. So what I want to do is I want to take AC and find its factors. So the factors of AC. And we'll do this step by step in a second. Once I know that, then I say, okay, well, which one of those adds up to give me B? Okay, and again, this takes out that guess and check piece that's tough for a lot of students. And then we're going to throw it in the box. For the box, it's always going to be ax squared, assuming it's a quadratic. This is for quadratics only. And then C. We're going to take one of these numbers, put it right here with an x. We're going to take the other number, put it right here with an x. And then we're going to start figuring out what we can take out here, what we can take out here, here, and here. Okay, so let's look and see what that looks like. Before that, though, we do need to take a second and talk about what factors are. Why are factors important? Why do we care? What do they give us? So factors give us zeros. Zeros are solutions or answers to problems. If I know what my factors are, yay, that tells me what my solutions are, and that makes it so I can answer the problem. We can also go backwards. If we have the zeros, we can find the factors and we can create a function. So looking at these couple problems here, I've got a quadratic. I've got, at the graphs, I've got a quadratic, I've got 3 cubics, and I've got 2 quartics. Well, looking at what I have, right, this is a quadratic, C, big C. This is a quadratic, and those are the only quadratics, so those must match up. Okay, again, good SAT strategy here, ACT strategy here. Those must match up. Those are the only quadratics. The cubics, I've got 3 of them. So let's look at the quartics first. My quartics are E and F. Well, if I look at E and F, okay, and I plugged in 0, because I crossed in different spots at 0, right? And if I plug in 0 to E, this is going to turn to 0, this is going to turn to 0, I'm going to be left with 4. Well, this one crosses at 4, so that must match up with this one, and then the other quartic F must match up here. Okay, I can use that same thought process for my other 2, or for my other 3, or at least to narrow them down a little bit, because this one crosses at 0, this one crosses at 0, and this one crosses at 2. So I should be able to find the one that crosses at 2. Plugging into little b, 0, 0, 0, I cross at 2. So this is my little b. So then the only 2 I really have to figure out are A and E. Well, there's a theorem in algebra that says I can plug in a number, just like we did with the 0 here, and whatever I get out, that should be my answer for that, right? I take in an x, I plug in it. Well, I want to take x's that are easy to calculate and easy to see on here. This one crosses at 1 and 1. Okay, well, that's not going to help me. This one crosses at -1 and -2. So on these, what I would do is I would take either -1 or -2, plug it in, and figure it out. Now, I probably want to plug into this second one here, little d, because it's shorter. And let's do -1 first, because -1 is easier to work with than -2. So -1 cubed minus -1 Negative 1 cubed is just negative 1. Minus minus gives me a plus. And there we go. So that one crosses at negative 1 at 0. So that must be A, which then leaves C. Okay, so again, we have this nice little idea of, hey, if we take these functions, we don't necessarily need to know all the parts. And again, I always come back to that. We don't need to know all the parts as long as we know the whole. Okay, so looking at the next part. Same idea, but what I could have done is taken those x-intercepts and multiplied them out. Remember, a factor gives us an x-intercept, or 0, and an x-intercept gives us a factor. The big key we need to remember is we just need to change the sign. If I have a factor, x minus 4, to get my 0, I just need to change the sign, assuming that x is 1. If not, then I do need to set it to 0, but in this case, it's 1. So, or the coefficient is 1, so I can just change the sign. So if I know my x-intercept's 4, then my factor is x minus 4. If I know my x minus 4 is my factor, then my 0 must be 4. Okay, so if I knew all my zeros, I could get all my factors and then expand it and find these functions. So I could have done that as well on the last one. A little bit more work, though, than what we did. Okay, so let's actually talk about some factoring now. So again, we're going to be doing diamond and box on all of these problems. First step, every time GCF. So starting with the first one, I'm going to take a GCF out. I can take an X out of all of these. Please, please, please make sure you're doing GCF. This is the most common thing I see students forgetting, and it's not a hard step if you just get it done, and then it's going to make your problem so much easier. So I take those x's out. I'm going to put the x out front. X squared minus 4x minus 5. Now at this point, I want to ignore that x on the front, and I want to look at just the inside. So I'm actually going to just take it, rewrite it. X squared minus 4x minus 5. Okay, thinking back, I need to identify my a, b, and c. Remember, we have an invisible 1. In the diamond, it's always going to be a times c, negative 5. Negatives matter, so make sure you bring those with you. In the bottom, we're going to just do b, negative 4. Okay, now I need to find the factors of negative 5. So, this. Well, there's only one set of factors, and it's 1 and negative 5. But I can also have it the other way, right? Negative 1 and 5. And then I just need to take this, okay, well, which one of those pairs adds up to give me negative 4? And it's going to be this first one. So 1, negative 5. Coming over to the box. Remember, the top box is always just this first term. I don't really need the 1, but I'm going to put it just in case. Last box is always C, and again, bringing negatives with us. Here, here, with an X. This one, the negative 5, also with an X. Okay, and it really doesn't matter which order you put these two last ones in, just make sure you're consistent. I'm going to circle here. Now, the biggest thing I see with students on this step, when they get to this step, they're like, I don't know what to do. Circle the first column, please. It focuses your eyes on that part, and it makes it easier. I promise. I know it seems silly, but please do it. It does make it easier. Then I'm going to say, okay, well, what can I take out of both those? Well, I can take a 1, and I can take an X. So that's the first spot you want to do. The second spot you want to do is over here, where you say, okay, well, what times 1x gives me 1x squared? Well, another 1x. Third spot down here, what times 1x gives me 1x? That's going to be a 1. Last spot over here, what times 1x gives me negative 5x? Be negative 5. And then just to check, we always want to check this last box. 1 times -5 gives me -5. Okay, so then my answers are here on the side. So x plus 1 and x minus 5. Okay, now I need to remember, we can't just get rid of that x we started with. We do need to bring it back at the end. So I need GCFs. Forget them for while you're doing the box, but bring them back at the end. Okay. Go ahead and pause the video if you need to get the rest of this down. I'm going to be deleting it and moving on to the next one. Okay, for the second one, same process. GCF, what can I take out? 3y squared, or cubed, sorry, and then 3y cubed. So for the first one, I'm going to be left with 2y's, or y squared, and then 16. The y's go away. There's something still there, though, so I don't want to delete the y cubed, or put a 1 there. And then I took a 3y cubed out. Okay, now people freak out on this one because there's no b term. There is, though. Remember last unit we used placeholders. That's what we're going to do here too. So I've got -16, 0. Factors of -16 are 1, -16, 2, -8, 4, -4, which at this point I can really stop. I could keep going. I could keep going and doing -8, 2, -16, 1. But once you find the one you're going to want, you can stop. You don't need to show me every single factor. So 4, -4. Box. Taking the front term, y squared, -16, 4, with a y this time instead of an x, and then 4, negative, with a y, circle. What can I take out of both of these? A y, y. What times y gives me 4y? Oops. Sorry. What times y gives me 4y? It's going to be 4. What times y gives me -4y? So again, we're kind of going backwards on the area model because normally we would take the outsides and get the insides. Now we're starting with the insides and trying to get the outsides. So then I'm left with y plus 4, y minus 4, and then I need to bring back my GCF. Okay, so again, one more time, if you need to pause, go ahead and pause now. Okay, last one, and this is the important one because this is the one that if you don't do a GCF, your life is going to be miserable. Because if I take 5 and multiply it to 45, I get 225. 225 has several factors, and it's a lot. And I don't want to deal with that. I don't want to deal with that many factors when I can take that down by dividing by, 5. So that's what we're going to do. We're going to divide by 5. And we also need to take some z's out. Please make sure you're taking those variables out too, because some students, what they do is they don't take the variables out and then they look at it and go, I don't know. Okay, take those variables out too, because remember, we wanted to get it down to squareds if possible. So then we have 5z squared. We're left with a z squared plus 6z plus 9. Taking the inside, 9 from 1 and 9, 6. Factors of 9 are just 1 and 9, 3 and 3. It's much nicer than having to deal with that much larger number. In this case, I'm going to want 3 and 3. So z squared, 6, 3, z in this case, 3z, circle, z times z gives me z squared. 3 times z gives me 3z and 3. Okay, so then I have z plus 3 z plus 3 and 5z squared. Okay, now you may need, depending on the program, depending on if you're on an ACT, you may need to combine those z plus 3's and say 5z squared, z plus 3 quantity squared. Okay, because remember, anything times itself is just a square. Okay, and that's the basics of factoring. And if you're comfortable with that, that's good. If you're not, make sure you are getting that extra practice. We're going to skip these for now. And again, if you have any questions, feel free to email me on those. This one, though. This one's a cubic. So I look at this one and I go, okay, well, let's check for a GCF and see if we can get it down to the square. There's no GCF here. Okay. These ones are actually easier, believe it or not, than the squareds because you don't have to do a diamond. Watch this. I'm just going to take the numbers and put them in my box. I'm going to put them in an order. I'm going to start with z cubed, 5z squared, negative 4z, and negative 20. I'm just going to throw them straight in the box. So if you've got a cubic, this does not work on the quadratics. You have to do this on the quadratics. Okay, I promise you have to do this on the quadratic because the idea of the diamond is it really gives us the 4 terms we need to put in the box. The boxes on these always have 4. Here I already have 4 terms, so I don't need to do something that splits the terms. But at this point, same process, do the circle. I can take a z out. Z squared times z gives me z cubed. Negative 4 times z gives me negative 4z. And then 5 times z squared gives me 5. And then negative 4 times 5 is negative 20. So on this one, it is z squared minus 4. Z plus 5. Now, I do want to be careful here, though, because it says factor completely. So far, everything we have done is correct. But that completely part tells me that I need to double check that I am completely done. Well, I have a quadratic here, that z squared minus 4. And that z squared minus 4 looks very similar to that other one we did. And I'm going to let you do that work by yourself because I don't want this video to be too long, but it's going to turn into z minus 2, z plus 2, z plus 5. Okay. Factor theorem. The factor theorem says that if I have a factor and I plug it in and it's truly a factor, then I should get 0. This goes back to that synthetic division piece we did where when we did synthetic division, if it ended up at 0 or long division, it ended up with a remainder of 0, then it was actually a factor. So let's look at a couple of these really quick. I know this video is getting long. Sorry, I'm trying to go quick. So determine whether x minus 2 is a factor of this function. So what I want to do is I want to take this, change the sign to positive 2. So I'm going to do f of 2 in this equation. 2 squared plus 2, sorry, let me put parentheses around that, 2 minus 4. Well, this is going to be 4 plus 4 minus 4, which is 4. So this is not a factor of that function there. And in fact, that one does not factor nicely. The next one, same idea. We're going to do f. We're going to change the sign of negative 5 and plug it in for this guy. 3 to the 5, or sorry, to the 4, or negative, sorry. 15 negative 5 cubed minus negative 5 squared plus 25. I want to be careful here that I am making sure that I am keeping those negatives where I need them, especially with the parentheses, because if you put this in the calculator, it's going to be important that you are following the rules there. Okay, let me pull up my calculator on my phone and do this one really quick. So I've got 3 and then negative 5 4th plus 15 negative 5. And again, making sure I'm using parentheses to the 3rd minus negative 5 squared plus 25, and I get 0. Okay, so since I got 0 this time, that means that this is a factor. So for this one, it is a yes. For the first one, it was a no. Okay, well, how does that help me? Well, on this one, I've got a quartic, and I haven't shown you how to do quartics when it comes to factoring. So I want to do that here, okay? Now, I'm going to go ahead and tell you this one does work nicely, and I'll show you why. The other way we can do this, instead of plugging it in, and this is actually going to help us because it asks us to factor completely, is to go ahead and just do synthetic division. So negative 3, negative 1, need to leave a placeholder for that x squared, 3, and then 1, negative 3, because I changed the sign, drop, negative 3, 0, 0, 0. This is going to be positive 3, which is 2. Oops, wait, hold up. Made a mistake somewhere. 1, negative 3, 0, 0. Oh, this should be 0, sorry. Which means this is negative 1. I was going too fast. Negative 1, and then negative positive 3, 0. Okay, so remember, because I have a remainder of 0, then this truly is a factor. So then we have x cubed minus 1, and then x plus 3. Okay, if this had turned into a squared for me, then I could have taken that a step further. There is technically a way to do that one, but we're not doing that one this year, so you don't have to worry about that. But that's how you would do that. And then you would check in to see here, can I factor this? If you can, yay, let's factor it. And if not, then you're done. Okay, and that's it for this lesson. Again, sorry, it's a little bit longer lesson, but it should be reviewed for most of you. If you have any questions, again, of course, feel free to email me or send me a message on Canvas. I will talk to you guys later.